Today I will talk about what we are able to do with digital technology for facade elements. And the goal of this talk is to see how we can give shape to the matter. So I'm Didier Lootens, I'm head of Department of Digital Technology in Sika Technology for almost 20 years now. So when we talk about constructions, we have an idea, this kind of buildings. And it's interesting to see what happened in 100 years, that you can see that it was in New York on the left side and the right side is in Toronto. And between these two pictures, you have 100 years difference. And we don't see so much difference of the construction type. The only thing that you can see is the difference of the safety. That means that in 100 years, we improve a little bit the safety, as you can see in this video. So what happened with the time? We are building more and more in no more on site, but in the production, like you see here. And the same, nothing changed for 50 years. That we were also building in modular building for 50 years. You see the main difference is that before it was with the people inside, so more productive, but less safety. But it's interesting to see that we have a lack of automation in constructions. And if you compare automotive, which is in the industry 3.0, to construction where we are, let's say at the level almost 0.0 with a lot of people manufacturing, we see that we need to make a huge improvement in the construction for the rentability, the profitability, and the improvement of that. So we can see evolutions, but not revolutions in the constructions. When we look at the surface, the panel, the beauty of the buildings, you can see that when we are building on site, we are able to make flat surface with a mold, and we have this kind of building as a consequence. You can improve a bit with the color, but for the aesthetism is not the best that we can see. We have also other issues with the building that we're building now for the rebar. When it's made on site, we may have accident like the bridge that we are collapsing, where we were able to build 2000 years ago, perfect bridge without any issues here in France. And the goal is to do the same with digital manufacturing, but without the use of slaves. So now when we look at the history of other companies, and not in construction, but in digital, like Kodak and BlackBerries, both make bankruptcy because they were not able to make the transition to digital. And this is what may happen also for constructions company if they are not making these transitions. And there is something which is extremely important for us. It's the value, the added value that we have in our product, which is a function of functionality over the cost. So it's easy. If you want to increase the value, you can increase the functionality or decrease the cost. How we decrease the cost? We can have cheaper formulation, cheaper material, cheaper production, cheaper people. This is something that company can do. But what we can do much better is to increase the functionalities with the flexibility, the aesthetics, the design, the energy management, the building, breathable wall, 3D printing. There are many ways to increase the functionalities, and this is what this talk will talk about for the special facade elements. Example of facade element that made today. Synthesis 3D is a company based in New York City in USA, and they are offering different kind of design on demand that people can choose with the mold technologies. So they are explaining here that they are printing the different elements in plastic, and then they are pouring this element with concrete. You can choose the design, and then you can have the shape that you want for your facade element. So in that case, we are printing in plastic, molding in concrete, and installing the design. So it's exactly like here exposed in this picture. You make a mold, and you can pour with the concrete of different kind of design. And you have these beautiful buildings in Brooklyn, New York City, that was made with this design. You can see here the different element that was printed in plastic, poured with concrete, and then you have this large element of concrete that was installed in this facade. But that's a nice example how they are doing that. The issue with this technology is that you need to print everything in plastic first. You can reuse this mold, but if you reuse, you don't have diversity of the design that bring 3D printing. And also you need a huge amount of plastic that then has to be recycling or thrown away. Another way to do that without using plastic, but with using wax, it's a company, Free Lab, that did this design in the metro Elizabeth Line Station in London. And in that case, they are printing directly with wax, spraying the concrete inside and making this block and installing this block. Advantages of this technology compared to plastic: it's easy to recycling the wax, so it's much more environmental and easier to do different kind of shapes. So it's much more flexible than to use plastic. Other way to do facade elements with 3D printing is to print most of the time in PET the different elements and to glue the elements to the building, like in this example for the Dutch Museum in Munich. So it was planned to be in 2020, but it's not achieved. And we can see that here the panel weight at about 10 to 15 kilograms per quadrat meter. So that meant a total for the facade of 12 tons of plastic. And this is important to see 12 tons of plastic because it makes a huge consumption of CO2. 12 tons of PET is about 30-40 tons of CO2 for the facade, plus the cost. Also, this technology is very slow. That means that to print a panel like that with a printer, you need about 1 day. So each panel of 1/4 of quadrat meter take 1 day to be printing. So you can imagine the number of days to be able to do this. You can see many examples of this kind of printing. So here, this is what you can see by another company. They print a huge surface area of 300 square meter with this technology. And it's beautiful, everything in plastic. So we can have the freedom of design with these technologies. Here's another example made by Dus Architects. They did that for the Dutch European presidency in 2016. Everything also made in plastic for this building. So we can see a lot of examples worldwide made with these technologies. Most of the examples that you can see are for small surface, very few large surface, due to the time that we need for this technology and the type of equipment and the total costs that you have for this. Here's another example by Bunch Technology in US company that they did that this year. Another kind of technology made with robots where they are printing all these elements and installing this element on the surface of these buildings. Another way to do a facade element with 3D printing is to 3D printing of powder. So this is powder layer by layer, which can be made with salt, cement, or gypsum. And you have also by emerging objects, this beautiful example. So here, example of buildings representation from Spain, where you can see facade elements. It's very rare to see that at large scale. So this technology is also slow and very expensive. And also the strength of the material is maximum 10 megapascal, which may be dangerous for facade elements. So now when we think about 3D printing is giving a shape to the matter and functionalities. And what we can see in different applications, not in construction, that in aeronautic, we are giving a complex shape for complex functionalities to save the weight. In automotive, they're also using that in production to make your shoes that are directly designed on your size. For medical, adapted to your body with a different functionality and that has to last a long time. For the food, you have this application. For the art, architecture, game, space also, or fashion. And you can see that for all of these applications, there is more than one functionalities that bring 3D printing. And it should be the same for the facade element, how we can bring different functionalities. So now when we look at the house or the design that we can see, we can have a house in clay, in glass, in plastic, wood, metal, blocks, or concrete. We need to see for each of these kind of design, what is the cost, the building time, the CO2 fingerprints, and also what we bring the materials in terms of acoustic and isolations. For example, a concrete house has a terrible acoustic or is not good for the insulation, so we need to add more layers. So this is what we have in most of the constructions. And the last panel that we are putting for the facade elements, we have a sandwich system of different elements that has to be most of the time glue or fixed together. And that means that for environmental and complexity and cost point of view, it's very high. And it looks like the cakes that we have in France. This is a millefeuille, so 1,000 layers. This kind of structures that we have for the buildings. And it would be nice to simplify the structure to be able to build more efficient, faster, and to add the aesthetism of the facade. Another point that we need to check is that the CO2 and the energy that you need to give for each buildings. So you can see that the annual productions of concrete, cement is very high compared to wood. It's 20 times more than wood, for example. And plastic is more than 2,000 times more than plastic. And if you look at the energy that you need for the different elements, polymer, you need huge energy. So everything that I propose with the facade element polymer, very huge energy consumption compared to concrete, which is very low. So concrete need 1 megajoule per kilograms, where plastic need more than between 100 and 200. So it's very high. And that means that for the CO2, the carbon footprint, the facade elements that are present in PTFE, for example, or different kind of polymer, are about 1,000 to 10,000 higher than concrete. That means that 1 kilogram of plastic is doing 100 times more than the concrete. So it's important to see the carbon of each element that we are doing. Also, we need to think about the life cycle assessment of the different products. Each building that we are building will be destroyed, and what we are doing for the different part of the materials. And you can see that the recycling of all the materials outside of the steel is very low. That means that we are not recycling so much, so we need to think more about the life cycle assessment for the quality of our materials. So people like to consume, and this woman is saying that food is good and it's good to consume, but we know that if we are eating too much, we have consequences, and that's the same for the building. We should reduce our consumptions, and this is important to reduce the quantity of CO2. And we can see that the carbon footprint or the carbon consumption of the function of the time is exploding, with the consequence that we can see in our weather. So we need to add functionalities in the product that we are doing. And the first functionality that we can think for facade element is to add a color. So putting color in a building is not easy to make it nice. So here you can have an example of Winsu putting strange color in their buildings. You have better example of Europe, which is doing in ceramics with a blue color and beautiful color. So this is one more functionality that you can add. But there is other functionalities that are even more useful to add some vegetal to the building. So here you have in Berkeley, a nice example, or in the Genesis Eco green system 19, where they are integrating green inside of the printing element, so that you have one more functionality, which is not for the only for the beauty, but also for the thermic, because the more it's like a green roof, you can cool down your building with the additions of the green part. You can add another functionality with the element that you print. You can add light. That means that you can make a porous medium where you can control to make a design, and then the light is able to go through, so you have more light with a beautiful facade element. You can add another functionality, and this is good to see from the past how the buildings were made. So here you have the Hawa Mahal in Jaipur in India, which is a beautiful structures. And you can see that all these openings were made for cooling the house, the buildings. So this is a beautiful way of cooling hot countries. And this is something that has been reproduced by many research. So that means here with this cooling system, with this hole, or made with clay, concrete, plastic, or whatever the kind of materials, you have with the facade element, with the beauty, another functionality, which is the air condition without need of energy, just by the air going through, which is needed to cool the buildings. Then you have another application, which is for the acoustic. With 3D printing, you can make a shape which make better the acoustic of the building. So here for a concert hall. And you have many examples here. It's also for the heating. Depending of the shape, you can make the acoustic much better, and adding, in fact, shape and beauty is also adding improvement of the acoustic. So this is something that we can make with the complex shapes that you are printing of your different objects. So when we come on 3D printing, we have hundreds of examples of 3D printing house and building on the road. And there is something which is very common for all of them. Most of them, they don't have a nice surface printing. I mean, it's not regular. So they are doing some design, which is nice, but it's not regular and it's full of defaults. So that means that there is something that we can improve. So if we take an example of nature additive manufacturing, here we can see a certain surface, and you can see that additive manufacturing is not new at all. It was made from the 50s in US, and they were able to print already a medium quality surface with different functionalities. So when you can see that the house, people are saying that additive manufacturing is new, it's not new at all. It's for a very, very long time. And at that time, they were already able, with one guy, to print an entire house. So today, when you see the kind of building representative, it's not very nice surface. That means that they need most of the time to paint or to put a coating on the top of that. And it would not be the goal. The goal is to print directly a nice surface so that we have not just structural, but also the facade element included. This is what we did with one of our clients, Basics in Dubai. They were printing the different facade elements of their headquarters in Dubai. And we can see here, print this facade, and then they were putting the different facade, one over the other one, to have a nice surface. But we can do much more than that. That's what we did with our clients, or two clients in Utah in USA and in Switzerland, at Fantranger, where we installed this complex printer system to print very quickly. And I will show a bit what we can do with that. And we can print different facade elements, but also structural elements which have facade functionalities. And the beauty of this production, they are operating with just one person. So we went to train the people for 2 weeks. And after 2 weeks, one single guy can operate all the production alone. So in this big production, only one person is working. So this is what they are doing. Here we can see this is a basic surface of concrete with a mold. We can make flat surface, but we can make a texture surface. We can add different contour. We can add one color, two color, or infinite series of color. So the color on demand. Also, we are working on the texture and the form, the shape. We don't want to do concrete shape like we are doing now with the mold. With 3D printing, you are able to make a complex shape with a nice organic shape. And we are also working on the design of the buildings, how you can make all the buildings, not just like did the Corbusier with a slab and the column system, but how you can integrate all kind of new technology to be able to build all together. So here are some example of what we are doing. So we are doing the columns which have different design, also playing with the color and the shape. And this is a competition that won my kids. Very simple, little boats that was printed in 10 minutes, and then they could go to the sea with this little boat. But coming back to the facade element and how we are printing. So when you have a design, like here we have a design of a bench. This is a design, we slice it, and then we print it. This is printing in 20 minutes. And then this is the texture that we have. So for the facade element, we did some example of this kind of texture. And then we put here for inside of a house with some light, these panels. So each of these panels were about 100 kilograms and put directly on the wall. But we're doing other kind of design. So outside here with a large difference of XZ texture, or we can even print with some anchor or some shape or some draw inside of the draw. And here you can see different kind of example of facade element which are directly glue on existing buildings. Other examples that can be organic, inorganic shape, and that each of these panels is printed in less than half an hour. And it's quite important that one person operate, and in a half an hour, you have this panel that can be directly built for the buildings. So some of them are glued directly on the surface, some of them have the functionalities, structural and facade element. Traveling a little bit in the world, so this is the Babylon, the gate of Babylon. And in the gate of Babylon, you have this row of different animals, which are made in bricks. And I wanted to have the same for the entrance of my office. So what we did, we took one of these animals here, the lion, we 3D scan it, we slice it, and we print it. And with a bit of light, you have the entrance, which is exactly like the gates. So this is also facade element that you can make on an entire building. Another example is Machu Picchu, so more near your place. And in Machu Picchu, there is one specific construction, which is the ashlar construction. That means that all these huge stones are built without mortar and without steels, and they are resistant to the earthquake. And it's interesting to see how they are doing that with different shape. And you can do see facade elements which are exactly the same, built in the same way. And this is an example inside, but we can do the same outside. This is also in my office. This is a basic design where you put, let's say, all kind of sculpture or books. And we can also assemble that very easily. This one I built in a couple of hours directly in my office. Another example of facade element, more green. This is what you can see behind me. This is very good for the acoustic, for the aesthetism, but also for the quality of the air and the humidity. It's regulating everything. So here you have a facade element which has the functionality of the beauty of the acoustic, but also regulation of the humidity and the CO2 in the office. So that's what I wanted to explain in this presentation, that we can add many functionalities with this different kind of design. Another functionality that we can add, this is a building that we are making in Switzerland. So here we can see all these panels here are printed. It's difficult to see, but this is the stone. And why we print this element is in fact to control the sun intensity on this panel. This house is a passive house. That means that we don't have any heating system in this house. It's regulated all the year long. That means that when it's built, we don't need any more energy than for the light and the machine, but we don't need any energy for the heating or cooling system. Inside of the house, the temperature is 20 degrees all the year, thanks to a special construction of 3D printing elements. It was made by Van Trangerbauer. So there are evolutions with digital manufacturing, and these evolutions is not the one with the stronger, but the one with the most adaptive. And many people are afraid by robotic. We should not be afraid of robotic. They should be, we should work together. So here, what we can see, you have some sitcom putting the robots that are making our task, and we can be afraid of that. It's not the case. The robotic is used now to be able to make repetitive tasks and hard tasks that will replace human. And the goal is that we are working in what we are the best. That means on the design and the creativity. And this is what we are doing in my lab every day. We are manufacturing new materials, playing with the materials, and jongling with that to be able to make new shapes. And the goal is to bring shapes with the matter. That means that now work more with software, more with the materials, to be able to have products with higher complexity, higher functionalities, and much cheaper than what we are doing today. What I present, what's doing the clients in Switzerland is much cheaper than the way we can build with conventional manufacturing. So that's a good way to see the difference between robotic that is able to do the repetitive task and human do the creativity. I'm open for different questions. This is how we print. You asked to put some music, so I put some music in my presentation. This is the first print we did about 4 years ago when I started the project. It was a huge pipe of about 3 meters on diameter, and it was printed directly with a robot. Okay. The presentation is finished.